Okay, let's see how to actually approximate the area under a graph in practice. Suppose we want to approximate the area under y equals 8 minus 1/2 x squared from x equals negative 2 to x equals 4. Now in problems like these, you'll typically see that we will tell you actually what n value we want you to use. In principle, you could pick something if you just are trying to make an approximation, but let's say that the problem says to use n equals 3. I'm going to use n equals 3. And then the other thing that a problem will usually specify is a kind of strategy for how you pick your sample points. And maybe I'll get there in just a minute. So first of all, I find it useful to actually sketch a number line that goes from negative 2 to 4. Just sketch your interval here. We don't need to draw the graph itself, but this is really useful so that when I go to divide it up into pieces, I can sort of divide it up appropriately. Now remember that delta x, the width of each piece, is given by the original length divided by the number of pieces. And it's useful to calculate that. So in this case we get 2. And so now that just means I'm going to put a new tick mark every 2 units. So from negative 2 up to 0, 0 to 2, and 2 to 4. So those are my 3 pieces. Now we want to pick some sample points. Well, it doesn't really matter. In principle, you could just pick a completely random point in each of these 3 intervals. In practice, we usually use one of 3 strategies. Either we pick the left point in each piece, or the right point in each piece, or the midpoint of each piece. And I should mention that there's no reason in particular that the midpoint is a better choice exactly, but that's a good sort of default choice anyway, and let's just say that the problem says to use the midpoint. So let me mark those in just a different color here. So just halfway between those values here, so at x equals negative 1 and 1 and 3. Those are the x values that are going to be my sample points. Right, in other words, those are the things that we called x1 star, x2 star, x3 star in the last lecture. Okay, so now what we want to do is to put these sample points into the function f and use those outputs as the heights. And you might want to actually collect these together into a nice table. So let's take my sample points, x1 star. Maybe let's write it like this. So let's make a table where I have xi star and f of xi star. So we had negative 1 and 1 and 3. So f of negative 1, I just plug that in right here. That's going to get me, it looks like 7.5. F of 1 also gets me 7.5. And f of 3 is going to get me 8 minus 9 halves, so that's 3.5. Okay, so these are the heights of your sort of staircase function. Well, it's useful now to maybe find the areas. And remember, the areas come from taking f of that point times delta x. And well, delta x is the same for all of these. It's 2. So I'm just going to double my f's in this case. I'll get 15 and 15 and 7. And then if I add all those up, I get a total area of 37. Alternatively, you could add up all of the heights and then multiply by delta x. Because, of course, if I have something like f of something times delta x plus f of something else times delta x and so on, well, that's the same thing as just factoring that delta x to the outside and then doing all the f's first. Okay, so when it comes down to it, there's really not a lot of very complicated calculations for approximating an area. The only tricky part is to make sure that you kind of organize yourself well, that you picked the right sample points, and then you just have some simple calculations to add things up.